Okay, so you join me messing around with this damn thing again. So I haven't finished it because I'm one of those guys that never really finishes anything unless he's really pushed to do it. And I sort of promised some people at work they would have this at some point. And it's counting my work social media, so I do need to finish it. And so I've already done the bit where I've achieved what I want to achieve. Creating a finished product is never really what I want to achieve. It's just learning how to get there. That's sort of what I want to do. Anyway, we're going to finish it. So I just need to sort out power and then we're done. Everything else is just, I've got to glue the front on and that's it. So I've considered all of the options available to me. I've learned a lot from doing the outside temperature sensor thing, and with the ESP8266, it seems the easiest solution is usually just getting a low quiescent current voltage regulator like this one here, which is freaking tiny. It's a SOT89 and it is a HT7333-A. So it's a fairly low quiescent current voltage regulator. I think it states in the data sheet there's something around 4 microamps. So that's all right, I'm fine with that. And the sleep current on the ESP8266 is around 10 microamps, so it should be okay. I'm going to be using 4 AA cells, so the quiescent current on that voltage regulator may increase from that datasheet value. I would use 3, but I think before the batteries had run out of all of their energy, it would drop below the dropout for this. So I think 4's fine. And also, I was going to run them off just a couple of AA's, but it didn't really work for very long. And then I was going to run it off 3 AA's, but nickel metal hydride ones that I discharged slightly, so down to about 3.8 volts total. And then that seemed to be okay. I was going to drop it with a diode. However, if someone had thrown in, fully charged alkaline batteries, it's going up to like 4.5 volts, isn't it? So I didn't want to leave it and someone replace the batteries. So voltage regulation is going to be the easiest and safest way to make this work, and it will last a long time on 4 AA's, I'm sure. So we've got a little adapter board here. It's got, let's zoom in a touch, shall we? There we go. So we've got a little adapter board. It's got an SO8 sort of footprint on one side and TSOP 8, is it? Is that how you say it? It's TSOP anyway, it's small. On one side, on the other side, and luckily SO8 just happens to fit these little SOT89 just. So if I can align it correctly, it's going to be a difficult one to solder. I'm just going to push it in with a pair of tweezers, I think, but it'll fit. So you can see there that they'll fit on, that'll be fine. Blue Tech might have to get involved, but it'll work. And I've got a few caps here I'm going to be using, but the most important thing is I've got a little adapter board, I don't know, a shield, unpopulated shield that goes on the top of here. It's not in focus. Let's try and adjust that. There we go. So it'll sit on here, round about like that on the pins there. And I've got some of these ones which I'll be using. These are just these little header pins. I'll throw them in and then I'll pop them in the top. Oh. Go on, lad, in you get. Good, so I'll pop them in there. This will get soldered on there and the other side as well. And I'll make sure I've got my circuit all sorted too. Now I'm gonna add a switch. He says. It's hard to read, isn't it? There we go. So I'm going to be using this, and I've used it on things that run at about 750 milliamps before at fairly low voltage. So I don't know whether this is going to be appropriate, but it's basically always going to be switched on. It's just in case it needs to be switched off for any particular reason. I don't want to have to, yank the batteries out every time I want to switch it off, if I do want to switch it off. So I'm going to be using that. And so now I'm just going to go away, quickly have a little figure out of the circuit, and we'll come back and do some soldering. So I started designing up a little circuit. I laugh because I sort of gave up. I think I'm just going to wing it. I'm pretty sure I know what I'm doing-ish. or at least I know where bits are going to go. So I'm just going to blue tack this to the table and gingerly solder a couple of pads and then maneuver the thingy on. So the regulator on. So I think I'm just going to solder up this pad here. I know my orientation here. I know where the pins are going to be. A little bit of solder there, that should be fine. Do you know what? Just to help this along, let's, although I have flux has just come out of that solder, but let's just bung a little bit more on. Hope that pin sort of drop in nicely. Are they raised up a little bit? No, they're okay. So we're just going to slide this on and hope that those pins aren't too raised off the pad. There we are. That looks fine. The others look fairly well aligned. Now all we need to do is just touch a little bit of solder on those ones. There we go. And the last one where I burn all the blue tack off. So, well, okay, we'll just go for it and see how badly that works. No, that looks all right to me. I'll bring it up a little bit closer and hopefully I can focus that close. Yeah, that doesn't look too bad. You'll have to excuse my nails. I sort of bite them, but that's all right, isn't it? Yeah. Actually, that first pin could do with a little bit more solder. That is the voltage out pin. So let's bung a little bit more on that and then I'll move on. Now I'm only using 3 pins on one side, so I just happen to have some of these pin headers in a 3, so I'm just going to use the 3. So this this pin at the end here corresponds to the pin right down here. That middle one there corresponds to that one there, and then this third one corresponds to that pin there. So we don't need any more than that, and so we can just solder this on. In terms of structural support, it's not a heavy piece, so it doesn't matter if it's only got 3 pins soldered. And there we go. Happy with that. So I'm going to solder in this switch first. It's got 2 little support bits here. In fact, it could come one further over, couldn't it? Because we have the space. So maybe it's better just putting a little bit more space between it and the other components. It's probably a good idea. There we go. So if we solder that on, so these are our connections. So it's the center pin is common. I don't know if that's the expression you use, but essentially you're switching the 2 outside pins to always connect to that center pin. So I think the center pin is going to be my battery, and then the it will switch to the 2 outside ones. I don't know why, but I might want to throw the battery off to a different connection at some point, so I thought it might be best to do that. So next up, let's find the battery box. I think it's probably a good idea. Right, so I've got my little 4 AA battery box. Now another thing this is really good for is weight. It's going to weigh this down quite a lot because it's sort of an overhang design, so it needs some weight in the base. I'm just going to measure the voltage here. I think I've got them the wrong way around. No, 5.08 volts, so 5 volts, which is good. They should be relatively fully charged. Relatively fully charged. What does that even mean? I think they're fully charged, so we'll be going with that. So I'll just reposition the camera so that I can solder. Right, oh, I've trapped my solder. There we go. So I'm just going to quickly tack these on. There's blue tack underneath them, so hopefully I won't burn into that too much. I say tack them on, these are just the permanent connections. I'm not worrying too much about it. So they'll be fine. A little bit of blue tack there, and some solder on the top connection. That's nice, that's good. That's what I wanted to see, that it came through a little bit. So that's where we've got it. I shall solder a little bit on the top to increase their stability a little bit, I think. Stop them sort of shimmying off when they inevitably move around a bit. So let's just pull those back a little. Don't want to expose too much of the heat shrink, but I do want to ensure that they're fairly well soldered in. Okay, and then we want to solder that middle connection, so I'm going to just blue tack this down again. Use a fairly large chunk that way. Oops. Now, the middle pin is actually going to connect to the bit of wire, so we're just going to bend that over. It's really hard to see, isn't it? See if we can come in a little bit closer. There we go. There's a tiny bit of wire there. I've just bent it over and I'm going to solder it directly to that middle pin. So I'm going to try and bridge that gap with solder and hopefully that will be okay. And then I think we're actually going to have to solder to that again in a minute. But let's see if we can do that. There we are. A little bit more, I think, just to reinforce that bridge. Nice. That's exactly what I want to do. I've realised by looking at this, it's really difficult for you to see what's going on, but the problem is I've completely failed to draw a diagram which took advantage of these this board layout. I can draw it as a normal schematic, which I'll do for you in a bit. I'll show you at the end so you can see what I've done. But it's like stupidly simple. It's just battery, switch, regulator, probably some capacitors if I can fit them in. And then a a wire from D0 to reset for deep sleep, and that will be it really. But we'll carry on. So I've just soldered in my regulator, and so that sort of flips it that way. So the regulator actually turns this way with the pathing on there, and then we're going to look at getting the voltage in connected and then voltage out connected and ground. So I've cut a few little bits of wire here, a few short bits. I've got some more to go, but we'll start off by connecting up, what is it first? So we've got V out is the very first one over here, scarily next to ground, but that's okay. So I'll just pop it through. I've trimmed enough on these so that I can bend it over and bridge those gaps. It's super hard to see, but let's do this. Try and get through this swiftly because time is dragging on a bit. Hopefully that isn't too hot to touch. It sort of is, but if I bend that over, that looks fine. And we'll just bridge that. Is that voltage out? Let's have a little look again before I do solder. Yeah, that's voltage out, that's fine. I think I'll test it before I solder the connections to the board though, as you would. There we go. And then the last one is ground. I've put a fairly long wire on this one, but it doesn't really need it. Just being cautious really. Whoops, that's my phone. See, I have a life other than YouTube. Right, they're soldered. And then that's also soldered, so perfect. Right, so let's double check these connections and then I'll get the rest of the stuff soldered in. I'll also draw a little diagram for you at some point. Right, pretty much finished. This is the diagram as it is. So essentially this little development board here is just a little shield for the Wemos. There we go, you can see it now. And all that's on here, we've got, I didn't write that on. So, God, my phone keeps going off, how annoying. So we've got an HT7333A, that is the little board there. So it's on just a little breakout board essentially. We've got the battery over here connected to a switch. I've rather simplified that. It actually has 3 positions, this one, but any switch will do. And we're coming out through here through a 10 microfarad capacitor. A 10 microfarad capacitor could be 100, could be 1. I've just gone for 10. I don't even know if it's going to make any difference, but we just like to add these things usually. So generally it sort of stabilizes the output of your voltage regulator. You could also have one on the input, but the output's just fine. The Wemos has probably got enough capacitors on itself anyway, so it probably doesn't matter, but I've done it. And then the next thing I need to add is a wire jumper from D0 to reset. Now that is the deep sleep wake up pin. So this is going to go to sleep and it needs to wake up through reset and start the whole loop again. So I need to do that, and I don't have a wire. It's probably underneath this little sheet. So that will be the last thing I do, apart from pop this in a breadboard and solder these little pin headers in, and then we'll try it out, shall we? So just before I solder in the rest of the pins, I've just done that other connection, and then we're going to solder on these little headers. I thought I would show you that the voltage coming out is actually fairly good. Oddly enough, although I sort of read in the datasheet and then something about load regulation at certain current draws, but it doesn't read 3.3 volts unless it's drawing a significant current really. I had to put a 300, no, was it 150 ohm resistor on, I think, to draw some current. So yeah, interesting. Let's just have a look if it's currently switched on. I can't really tell. No, so it's that way. So currently 3.136, which is roughly the same as it was before it was draw any current. So it was a 3.14. So it's interesting, but that's certainly fine. I'm happy with that. So I'm just going to solder these on, and then we'll give it a go. Do you want to watch this bit? I might as well video it. I'll probably f it up. You know, I think soldering is one of my favourite pastimes. Mostly, I really like surface mount soldering. It really is. It's very, not soothing exactly, but it's very satisfying is what it is. So, let's turn this multimeter off, doesn't need to be on. Oh, hang on a minute. Let's just take one of these batteries out. Be a good idea, wouldn't it? Yeah, I find it fairly soothing. And ever since I bought this new iron, I say new, I've had it for a very long time. That pin is a little bit proud. We're going to have to push that one down. It doesn't look like it's sat in its socket properly. It's frustrating. There we go. I mean, I only really need to worry about ground 3 volts and reset and D0, but oh, that didn't connect at all. It's because I'm trying to do it a weird way around. So let's just turn it around towards me. So I think I remember saying something like, oh, I'm going to turn over a new leaf and finish some projects. Well, that didn't happen, did it? It almost never does when I decide that. I think I just have like one burst of energy and then, you know, it's back to work, like normal job work, and then I'm too tired when I get home to do anything. I say too tired, that's almost a lie. I mean, I play football on a Saturday night, so I can't even think now. Play football on a Monday night, and I have this intention that I'm going to go running, but I don't think it's going to happen. Anyway, this is done. Let's plug it in and see what happens, shall we? We'll risk it. There we are. So it is currently, well, if I put it in the middle, it's off. So let's plug it in. Which way round does it go? That way round, I think. Double check. Nope. You son of a gun. Well, I've royally messed this one up. Oh, why? I mean, okay, well, look, we're going to have to do a little bodge here because I may have just done this on a whim and not planned ahead, basically. So let me zoom in so you can see this. I was really tempted. I just sort of racked my brain for a minute to figure out, can I get away with this? Do I have to tell them? But I'm going to have to tell you. So looky here. This is the way round I've sort of soldered it up, which is rather unfortunate, isn't it? It's actually meant to be that way round, look. So you can see, I don't know how far, there we go. So you can see it's meant to be that way round. That is a bit of a bum, isn't it? So we're going to just have to do some freaking jumper wires around, aren't we? So that's going to plug in. Is it that way? I shan't plug it in because I don't want to, as long as ground doesn't go in anywhere. It's going to have to go in like that. So we're going to have to jumper 3 volts over to the other side over here where 5 volts is. That's easy. We can do that. In fact, it's right next to it anyway. Ground is going to have to jumper over the other side. That's okay. We could do that to where D6 is. And then we've got reset and D0. Those are the only connections on this board that we need to mess around with. So we'll do that, shall we? Joy. Right. So, okay, I've corrected my mistake, but basically what I should have done is line these up, not gotten so carried away and excited about finishing it that I didn't do enough prep. But then, you know, if you don't do these things, when are you ever going to learn? That's an important thing to look at. So yeah, make sure these are the right way around before you freaking mess around with it. So now we've got 5 volts going to 3 volts on this board. Let's zoom in and focus a little bit so you can see. So on this board, 3.3 volts is actually 5 volts on this little shield. And then reset is going to TX, but actually it's over here. So D0 and reset are going to be connected. So that means I've got my TX and D1 on this one jumpered over. So you can see that there. It's turned into a bit of a mess, honestly. Anyway, 5 volts is now 3 volts and ground is now D6. So we can plug this thing in now. Hopefully it'll work. I mean, I can't guarantee anything at this point. I am not sure, but that's it in. It's currently switched off, so let's switch it on and see what happens. Actually, I don't think it's connected to the net, but let's see if we can see it on. So if I bring my phone over, so we can see what networks are available, because I've put the little Wi-Fi manager thingy on here. So if I just turn it on, God knows which way's on, but it should see an LED. Yeah, a little blue LED there. And okie doke. Not yet. Does that mean it's already connected? Oh, it is. Hang on a minute. So, is that the time? Flip, it's late, isn't it? I've been doing this for ages. So it has updated, so it already knows the connection, the credentials here, so that's fine. Yes, it works. Turn it off and turn it on again. I know this is totally not ideal, is it? Let's zoom out a little bit. Maybe in focus. So you've seen a little flash down here. This should now do its little display thing. I put some graphics in there. Hello? Yeah, there we go. Okay, so it works. Now, if I just turn it off, we don't need it on for now. So this updates every half an hour. If I can sort of remember how I did this, there's sort of a, let's get rid of that now. A way to twist these around so that it becomes quite stiff. Ah, there we go. Stiff in here. Oh no. Oh well, that's because this isn't on properly yet. So once that is on properly, this will stand up. It's fairly heavy in the base here because of those batteries. So maybe I'll, once it's put together, I'll come back. But otherwise, if not, then thanks a lot for watching what was pretty much a very unorganized video. And probably familiar to you if you do some electronics. If you just want to do something in a hurry and you have zero prep time or don't make yourself any prep time, then you end up with crap like that. but still, it works, and that's the kind of crap I enjoy. So it's been nice seeing you, and I'll speak to you all soon.